Hi. Okay, so this is example number 2. All right, what do you guys think? I'm going to give you the first and second derivatives, okay? I'll take pity on your souls. Here we go. All right, so let's find where the first derivative is equal to 0, and then let's find where the first derivative is undefined. First derivative is equal to 0. At 0, and then it's undefined. At plus or minus 2. So we're going to go ahead and make our first derivative number line with -2, 0, and 2. So 0 came from the function actually being equal to 0. And then -2 was where we were undefined, and +2 was where we were undefined. Okay? All right, so to the left of -2, what did we have? Let's see, -3, -1, 1, and 3. Let's go ahead and test the signs of the first derivative on this guy. So, let's see. What is the denominator always going to be? We're always looking to work smart, not hard, right? What is the sign of the denominator always going to be? Positive. Good job. So do we have to really think about it anymore? No, right? We just have to figure out what the numerator is going to be. So if I have a negative times a negative, what do I have? Positive. And then here I've got a negative times a negative. So what do I have here? Positive. And then in between 0 and 2, I have a 1. I'm going to plug that in. I'm going to get a negative. 3 times a negative is a negative. So what is at this u here? An asymptote. What is at this u here? An asymptote. So the only thing that we can see if it's going to be a max or a min is 0. So we are changing from increasing to decreasing. Therefore, we have a max at x equals 0. I would plug that 0 into the original to get my maximum point. So it would be 1 over -4. So 0, -1/4. We have vertical asymptotes at x equals plus or minus 2. I think that's kind of all we got from here. Oh, increasing and decreasing. That's right. Increasing, decreasing. We're increasing from -infinity to -3. There's a break in the gap where we have an asymptote, and then we're increasing from -2 to 0. We are decreasing from 0 to 2, and then we have decreasing from 2 to infinity. All right, that's all the info we got from our first derivative. Let's get our second derivative number line. All right, same setup as up above. We're going to find where f double prime of x is equal to 0. We're going to find where f double prime of x is undefined. So the numerator is going to be equal to 0 when? Let's see. Anybody running into some problems? X squared equals -4/3. Yeah. He's never equal to 0, right? So we're good. Never equal to 0. But we do know that it has the same denominator up top. So we are undefined when x equals plus or minus 2. What does that look like on the number line? Let's see. F double prime number line. I'm going to put -2 here and 2 here. These came from the asymptotes from the denominator. Okay, so on either side of the asymptotes, what's going on here? Hey, is this graph going to have any points of inflection? What do you guys think? No, right? Because do you think an asymptote could be a point of inflection? No, he's not a point on the graph, right? So the graph could change its concavity on either side of the asymptote, but it's not going to, the asymptote is not going to be a point of inflection because it's not a point on the graph, right? Okay, so -4, I'm going to plug it into the numerator, and this guy is always going to be what? positive?
Yes, Declan.
No? Yes?
Boo,
What's it gonna be?
Declan.
Tell
Oh
me
wait,
what's
this guy's
function.
funky because no, I was like, oh, we can just ignore the denominator because,
It's
but it's
cubed,
not.
you
It's being
can't.
cubed, not squared. So we do have to think for this one. Let's see. Dang it, I hate thinking. Okay, here we go. So we got -4. He's squared, so he's going to be positive, minus a smaller magnitude positive, and then he's cubed, so he's positive down below, and then he's going to be squared up top, plus a positive, 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 positive. Okay, this guy's positive. All right. 0. Let's think about the 0. What do you guys think for 0? I got a negative number being cubed down below. What's that guy going to be? Negative. And then up top, I've got all positives. So this guy's going to be negative. And then the 4 is the same thing as the -4 because he's being squared down below. Perfect. Okay, so we have no point of inflection. We are concave up from, we should try writing the up. And by me, I mean we. So we're concave up from -infinity to -2, and then again from 2 to infinity, and then we are concave down from -2 to 2. All right, let's put it all together by looking at these on a calculator. And then just like kind of seeing if we can figure out what's going on here. You don't have to get out your calculator. You can just look at mine. We can just talk. Keep it light. Keep it low cortisol. What do we got? 6 over x squared plus 3. 6 over x squared plus 3. 6 over x squared plus 3. All right, what does this guy look like? Let's see. We got a max at 0, 2. Yas, can confirm. We are increasing from -infinity to 0, decreasing from 0 to infinity. Let's talk concavity, though. Oh, man. A POI at -1 and 1. Do you see? What do you think? This is an instance where you might want to draw your M&Ms, right? Can we hold M&Ms on this side?
Kind of.
Yeah, you can over here, though, right? Can you draw M&Ms on this side? Yeah, so that makes sense for that number line, does it not? Yeah. All right, cool. So, how did our first graph turn out? Pretty cool. Let's look at the next one. X squared. We're almost there. Don't die on me now, Declan. X squared minus 4. Oh my. Okay, so let's look at these number lines and see what we got going on here. Okay, so.
I see the two asymptotes. In case
You do.
Wow.
Perfect.
Holy.
Love it. Okay, what do we got though? We're increasing and concave up. Increasing and concave up. All right. Then we get to -2. All bets are off. What do we become? From -2 to 0, what do we become? From -2 to 0, so that's like this part, right? We are increasing and concave down. Does that make sense? Okay. Then, what's happening at 0? Well, we have a max. Yep, that makes sense. And then from 0 to 2, we are decreasing and still concave down. All right, that makes sense. Then we have our asymptote. All bets are off. Here we go. Back at it. From 2 to infinity, we are decreasing and concave up. You're going to have to be able to generate stuff like this on when we come back. But like, we're getting all the bones about it, right? Or we're getting all the foundation. Who's staying after for test corrections? Anybody? Okay, great. I'll see you then. Bye.